Welcome to Jennette's Pier. My name is Meredith.
My name is Dustin.
And my name is Flannery.
You're now on the Outer Banks of North Carolina at Jennette's Pier.
We are a 1,000-foot-long fishing pier, part of North Carolina Aquariums.
Today we will be teaching you one of our educational programs so that you can learn no matter where you are in the world.
Come along!
Today we're going to be learning all about plankton. So what exactly is plankton? Most plankton are super small, so small that you can't see them with just your eyes. We're going to need to use a special tool called a microscope today to see them. However, not all plankton are super small. This animal right here, the jellyfish, is not microscopic. You can see them with just your eyes. So we need to come up with a definition that includes all plankton, since we can't say that all plankton are super small. There's something else that they all have in common instead. It has to do with the way they move in the water. In the water we can have nectonic organisms and we can have planktonic organisms. Our nectonic organisms, like the fish and the sharks, are nectonic because they can swim. They can go wherever they want, whenever they want. Our planktonic organisms, like the jellyfish and like the microscopic plankton, are called plankton because they have to float or drift. They are not strong enough to swim against a current. There's two main types of plankton. We have phytoplankton and we have zooplankton. Now this red word right here, zoo, kind of gives you an indicator as to what zooplankton is, because a zoo has animals. So our zooplankton are our animal plankton, whereas the phytoplankton are the plant planktons. We're going to focus on just the phytoplankton first, so the plants. There's two main types of phytoplankton. We have dinoflagellates and we have diatoms. They have different characteristics, but they're both different types of plants. Now, if you guys are familiar with the character plankton from SpongeBob, you probably know that he's a little bit evil. Most plankton actually are not evil at all. They're really, really good for us. However, maybe some of plankton's evil qualities could come from some of the species of dinoflagellates. For some of these, if there's too many of them in the water at the same time, they can be toxic. But again, most plankton are actually really good for us. So why would these teeny tiny plants be good for us? Why would they be important? This is a picture of a plankton bloom, like if you were in an airplane looking down at the water. You can kind of see the green swirls everywhere. So why would these small plants be important? One reason is because plants give us oxygen, and over 70% of the oxygen on Earth comes from phytoplankton. Phytoplankton are also at the base of the food chain, so they're going to use photosynthesis, energy from the sun, to make their food, and then everything else in the ocean can have their food because they're at the bottom of the food chain. Now we're going to talk about our animal plankton, or our zooplankton. So there's two main types of this as well. We have meroplankton and we have holoplankton. Holoplankton means these animals are going to be planktonic for their whole life. So they're always going to be floating and drifting. They're never going to grow up to be bigger and stronger. They're always just going to have to go wherever the current takes them. Meroplankton, however, they're only going to be planktonic when they're really little. So this animal right here, for example, is a crab. A baby crab is going to be planktonic because it's floating and drifting. It's not strong enough to swim wherever it wants. But as it grows up to be bigger and older, it becomes nectonic so that it can swim around wherever it wants. So it just has a planktonic phase of its life. There's some sustainability challenges with the ocean, and that's starting to affect our plankton as well. First of all, we have microplastics, which are teeny tiny pieces of plastic from when plastic ends up in the ocean. It breaks down over and over and over again, and it's not good for our waters, not good for our plankton, not good for our food chain. We also have a problem with climate change, which is affecting the conditions of the ocean, and it can prevent some of our plankton from forming their shells properly. Some things that we can do to help with these challenges is we can stop using reusable or stop using single-use straws and bags, and we can use reusable versions instead. And then for climate change, we can make sure that we're always turning our lights out when leaving the room, and we can try to carpool with a friend when we can. So now that we know a little bit of information about these plankton, we're going to try to go catch some. So let's go see what we can find.
Alright, now we are on Jennette's Pier. We're going to lower our plankton net down and see what kind of plankton we can catch. All I have is a very long rope attached to my plankton net. The net is made of thin mesh so that we can let water escape while plankton gets trapped inside at the bottom. I'm going to leave this at the top of the ocean for a few minutes and just let the water flow through. The plankton are usually towards the top of the water because they need sunlight to survive. So let's drop this over and see what we can catch. Alright, now that we have our sample, it looks like nothing right now, but once we get in the classroom, we'll be able to look a little bit closer with our microscope. So let's go!
Now that we have our sample, we're going to look at it under the microscope so that we can see what is in it. We're going to do that by using a pipette. The way that this works is that we're going to squeeze the top of the pipette and then place it into our sample. Once we release the bulb of the pipette, it will suck up the sample. We'll then place it onto what we call a slide. It's a little piece of glass. This is our slide. We are going to do about 5 drops onto the slide, and now we are going to go place it onto the microscope. And here's our microscope, and you can see our slide is already on it, and we have our screen here where you can view what is on the slide. We also have these knobs. This one will go left and right, this one forward and backwards, and this one will help us focus. So right now I'm just going to look on here and see what we may find. Alright, so here on the screen you may see what looks like, I don't know, like a feather, maybe some hair to some. We keep looking at it and it definitely looks like maybe something that used to be alive. So we have a few theories on what this could be. A lot of times we find something that looks like it should be alive or moving and it's not. It could be a molt, exoskeleton of plankton. But we find a lot of things that are maybe a bit more difficult to identify in the moment. And right here I have a guide that I'll look at that try to help me figure out what I'm seeing. That was specifically phytoplankton. I also have a guide for our zooplankton, our animal plankton. So as we're looking around, I just found this circle right here in the middle. Usually when things are moving around, that means that there'll be zooplankton. But also usually if it's geometrical, not always, that means it could be phytoplankton. So I'm going to go to our guide over here with our phytoplankton and see what may be circular. And here we have a Cosconodiscus is our circle, and we have this circle here. So we can maybe not for sure identify it as a Cosconodiscus, but that's a good place to start at. So we're looking, and we have found what we have identified as a copepod. You can see him swimming around. I'm trying to track him a little bit. Now, he is what we call a zooplankton, so that is our animal plankton. And you can also see that it is swimming around. Now, our definition of plankton was that they cannot swim around, but that is against a current. This is still water, so they can move around a little bit if it's still water. There are so many species of plankton in the world that would be nearly impossible to discover all of them. But hopefully with the help we gave you today, you'll go out on your own adventure and discover some of your own. Thank you for watching.